Okay, hello everyone, this is Puya. Just want to continue on single phase inverters. Want to see more aspects of single phase inverters. First of all, I want to tell you that whatever we've seen so far, it's called voltage source inverter. Voltage source inverter. And in this course, we only focus on this kind of inverter. Another kind of inverter that we have is current source inverter. Okay, so in the voltage source inverter, we have a DC voltage that we want to convert to AC, and we usually have a capacitor here. Maybe you guys can think of why we need this capacitor before I explain it. And then we have our inverter here. And inside this inverter, we have switches. Here I'm just drawing a MOSFET with an anti-parallel or freewheeling diode. So you guys remember from the previous video that the purpose of these freewheeling diodes is basically release the current of the load when it's going in the opposite direction. Basically when the source is, when the load is supplying the current. So that's the basic schematic of, and here we have AC. Basic schematic of a single phase inverter. Now this capacitor that I didn't draw it in the previous videos, but we usually have it. Its main purpose is to filter out high frequencies. As you know that the capacitor's impedance is 1/J C omega, right? So when frequency is 0 for DC voltage, this acts as an open circuit. But for high frequencies, so omega increases, then this one becomes a short circuit. So basically it avoids having high frequencies going into our inverter. Now you guys are asking, where does the high frequency come from? This is like a DC voltage source. But this DC voltage can come from either a battery or a power supply. It can be a solar panel. It can be a dynamo. But it can also come from a rectified voltage. As mentioned earlier, it's very common in many applications such as HVDC, such as motor control drives for motor control and wind turbine generation, that we have AC converted back to DC and then converted to AC. So we rectify AC to DC and then invert it back to AC, right? If in that case, you guys remember that the rectifier, as we studied that before, it would have not pure DC, but it has like high frequency harmonics as well. So we want to prevent those harmonics to enter our inverter, right? Also, like if you're using a power supply, if this is like a power supply, there are chances that you have spikes as you turn on or off the power supply. So we want to make sure that we filter out those high frequencies using this capacitor. So this is a voltage source inverter. For current source inverter, so this is VSI, this is CSI. For current source inverter, we have an inductor, a huge inductor, and if you guys remember from our previous chapters, that this inductor can act like a current source, right? So in this case, we usually use a switch or it can be a MOSFET, or it can this time I draw a BJT, but let me just do it the same as what we have over here. Like this is like, okay, I'll do it as BJT because MOSFETs already come with anti-parallel diode. But let's just like say like we have a BJT and it would have a diode here. Okay, and the purpose of this diode is to make sure that we can have positive and negative voltages on the switch, across the switch. So here the purpose of this diode is to make sure that we can have both direction of currents going through the switch. Here like it's making sure that like we have positive and negative voltages here. In this course, we're only gonna focus on voltage source inverter. This inductor is usually very huge and it's usually very pricey. So that's one of the things that we should know about current source inverters. Now let's go back to the concept of voltage source inverter. There are switches here in the inverter. We saw that, for example, for a half bridge we had 2 switches, for full bridge we had 4 switches, and we'll see later in a 3-phase inverter we have 6 switches. These switches can be either MOSFETs, IGBTs, GTO, or in the older generations we had thyristors or SCRs, silicon controlled rectifier. Okay, so each of these would have their own advantages or disadvantages based on the voltage, based on the frequency, based on the price, based on the application. And as technology advances, usually the new technology as it comes out, it's very expensive, but as it gets more mature, it becomes more affordable. So nowadays like thyristors like are not used that much, but like if you see like an older inverter, you will see like thyristors there. But right now the